In this video, let's go ahead and practice finding the derivative of 3 different trig functions together. Real quick, if you'd like to download a copy of this PDF, you can find a link to that below, where you can also find a whole bunch of other resources as well for different types of topics. All right, so for number 1, let's go ahead and get started. We have the derivative of this sine of 5x. So instead of having a more complicated function inside, let's go ahead and simplify this a bit. So instead of saying d dx, let's find d du instead of sine of whatever this u is going to be. So we're going to go ahead and make a substitution. So notice we had this 5x on the inside here, and we're basically just replacing it with u for now. So on the side, I'm going to say what our u substitution is. We're going to say u is going to be equal to this 5x. That being said, the derivative of u, or du, is going to be 5. So just temporarily, we're going to replace this 5x with this u. And so let's just see if we're going to find the derivative of just sine of u. Try to go back and check your trig derivatives here, but the derivative of sine of something, or sine of u in this case, is just going to be cosine of u. So this is going to end up being cosine of whatever that u value is. I'm going to say cosine of u. Go ahead and use this purple color here. And once we do that, we're also going to have a du, right? So I'm going to go ahead and write du. Now, just like that, we just found the derivative of sine of u is basically just this cosine of u du. And what we're going to do next is, we didn't really have a u at the beginning, we had 5x, right? So let's go ahead and make some substitutions here. We know u is the same thing as 5x, so we can go ahead and swap that out. And we know du is this 5. So making those substitutions back here, we're going to say the derivative here is going to be cosine. And then let's go ahead and put that 5x in here. Okay, and then we're going to go ahead and replace du with that 5. So let's go ahead and multiply this by 5. Now just rearranging this a bit, I think people are typically going to write that 5 in front. So we're going to say this is going to be 5 multiplied by cosine of 5x. This would be the derivative of that function. Let's try another one together. For number 2, we have the derivative here of secant of this x squared. Now, similarly to the last example, let's go ahead and make a change here, make a substitution. So instead of d dx, let's find d du, and then let's find the derivative of basically secant of this u instead. So inside here, we're going to put a u instead of that x squared, and let's go ahead and make a swap here. So again, we're replacing this x squared with u. So on the side, we're going to go ahead and just write, okay, u we're saying is the same thing as x squared. So what would du be, or the derivative of x squared? Using the power rule, that would just be 2x to the first power, or just 2x. So let's go ahead and find out the derivative of this secant of u. Now again, this is just something you're going to want to have to look up or memorize. That secant of u, the derivative is going to be secant of u times tangent of u. So whether you have that all on a list of like as a reference sheet or something, just make sure you kind of know that secant of u is, the derivative of it is going to be secant of that u, whatever that is, and it's going to be always multiplied by tangent of that same u value. So I'm going to go ahead and put a u in here as well. Of course, don't forget, when you take the derivative, you also have to have a du at the end here, right? So we have secant of u times tangent of u du. That's going to be the derivative of this secant of u. So believe it or not, that was the hard part. So we're just going to now take this u and substitute back this x squared for that. And then for this du, we know that that was 2x, the derivative of it. And let's go ahead and put that back in. So our final derivative here is going to be secant of what? It's just going to be x squared. And then we're going to go ahead and say that's going to be multiplied by tangent of that same x squared multiplied by du. So we're going to multiply that by the 2x. And so while we had to find the derivative of the secant of x squared, we really just changed that x squared to u for a moment, found out that that's u, so du would be the derivative using the power rule. Then once you found out that the derivative of secant of u is just secant of u times tangent of u du, then you just go ahead and swap out the u's for these x squareds again at the very end, and du for the derivative of u, which is 2x. Here's one final practice problem. In this one, we have the derivative of cosecant, and we have this x cubed minus 5x. All right, so hopefully you're getting the hang of this strategy, but we're just going to go ahead and see if we can simplify this a bit. So instead of d dx, let's find d du and use u substitution. Make this look a little less scary for a little bit. So we're going to have this cosecant, and instead of that we're going to go ahead and put a u in place of that entire expression. So we're going to go ahead and say for a moment, just temporarily, that this x cubed minus 5x, we're just going to say that that's u. Okay, so on the side here, let's say this u is going to be equal to this x cubed minus 5x. And so what's du then? Let's go ahead and find the derivative. We can find the derivative of x cubed using the power rule is going to be 3x squared. And then the derivative of that 5x is just going to be 5, or the derivative of minus 5x is going to be that negative 5. So what is the derivative of this cosecant of u? Don't strain too hard about this. Either you have to memorize it or you have to look it up on a reference sheet, right? So the derivative of this cosecant of something, or u in this case, is going to be negative cosecant of u multiplied by cotangent of u. So again, just either try to memorize or look that up. So if that's the case here, we're going to say the cosecant of u, the derivative of cosecant of u is going to be negative cosecant of whatever that u is. Let's go ahead and write it just like this, multiplied by cotangent of that same u value. So I'll go ahead and do cotangent of u as well. And of course, there's going to be a du afterwards as well. All right, so the derivative of this cosecant of u is just negative cosecant of u times cotangent of u du. All right, so hopefully that looks a little bit less intimidating. And once we've done that derivative, or we differentiated, we just have to make some substitutions back. So these u's helped us make this look a little bit more simplified and less kind of scary. And so now that we're done differentiating, let's just swap back the u for this x cubed minus 5x, and then swap out this du back for this 3x squared minus 5. So we're going to go ahead and write this negative cosecant, and instead of u, we're just writing this x cubed minus 5x, multiplying that by cotangent of u, so cotangent of that same expression of x cubed minus 5x. And then du, we know, is going to be this 3x squared minus 5. So I'm going to just write that in 3x squared minus 5, and just put parentheses around just because we need to keep things grouped, otherwise it messes up kind of how we're multiplying things out. So I know the answer for this one happens to be a little bit long, but it's the derivative of this cosecant of this x cubed minus 5x. So there you have 3 different practice problems on finding the derivative of a few different trig functions. If you found the video helpful, please consider giving the video a thumbs up and sharing the video with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.